In Chapter 3, we're going to look at methods we use to collect data. And in Section 1, we're going to focus on ways we plan a study. So first, let's just talk about some terms about collecting data. So when we're collecting data, it's to better understand the characteristics of a population. So statisticians and researchers will often use a sample from that population to make inferences based on the summary results from that sample. So when we talk about population, it's the entire group we want information about. Now, when we talk about population, that doesn't necessarily have to be something like a large population, like everyone who lives in the United States, or even like the world population. It could be huge like that, like if we wanted to do all women, or it can be something small, like top 200 grossing movies in 2011. Or my population could be DACC students. So anything like that. The sample is then a part of the population that we actually examine to gather information about the population. So when we're talking about like the necessary sample size for something like this, it really varies and depends on a lot of different factors. And that's something that we're going to discuss at a lot of different points throughout this course, not just in Chapter 3, but when we move on to Chapter 5 and 6 and 7, we'll talk more about what makes a good sample. So it really is dependent. Now, we obviously know some sample sizes are too small. So like if I am looking at a population like all women and I take a sample of 10, we know that's very, very small in the grand scheme of things of like all women being our population. But if my population was my statistics students, a sample size of 10 may not actually be too small. It's very, very dependent on what your population is, and we'll talk about factors like that later on. There's also something called a census, which you may or may not be familiar about. So a census collects data from every individual. In the population. Now, the most common one that you may have heard about is the one that we do every 10 years in the United States. We do a census where we collect data from every person to kind of get an idea of the breakdown of how many men, women, children we have, breakdown of like races across the country. It does attempt to collect data from every individual. Obviously, there is some error there, but a census in general does not necessarily have to be like the U.S. Census we know about. A census is just collecting data from every individual. So if my population were statistics students at DACC, I could do a census of all of them and ask every student in that population. There are also two main ways that we are going to talk about collecting data. And the way we collect the data influences what we can and cannot say about a population. So the first one is something called an observational study. And what it does is it observes, it's part of the name, individuals and measures variables of interest but does not attempt to influence the responses. So a couple things about an observational study. So one, we don't impose any kind of treatment. And we'll talk more about what a treatment is later on. But it's basically what you choose that does attempt to influence responses. So a treatment is the influencing part. So a couple different ways you can look at observational data. You can collect it from a sample retrospectively, or it means data has already been collected and you look at it. Or you can follow a sample of individuals into the future collecting data. So that's prospective. And that's in order to investigate a topic of interest about the population. So a sample survey is a type of observational study. It collects data from a sample in an attempt to learn about the population from which the sample was taken. So like the census is a type of observational study. We're collecting data, we're surveying people just to kind of make observations about the population. The second type is an experiment. So an experiment deliberately imposes a treatment on individuals to measure their responses. And we're going to focus on experiments in a lot more detail later on in the chapter. So we'll go into more depth about ways that you impose that treatment and all of that stuff. So we're going to focus mainly right now on planning an observational study. So when it comes to planning an observational study, we can only make generalizations about a population if those samples are randomly selected or otherwise representative of that population. So if my population was statistics students at DACC, and I was asking students who were taking a different math class, that's not representative of my population. Another thing here is if you wanted to pull a sample of women asking about their shopping habits, you cannot take that result and apply it to men since they were not represented in the sample that was taken. So if someone or something isn't represented in your sample, you can't take that result and use it to make observations about them. Another thing about an observational study is it's not possible to determine causal relationships between variables. In an experiment, you can because you're imposing some type of treatment. But in an observational study, since you're just observing variables and gathering data, you can't make any inferences between those. So an observational study, you can make a correlation about the two. You can say, these are strongly correlated, which is what we were doing in chapter 2, but you can't say one causes the other. And if you have a well-designed observational study, you can apply the findings from the sample to the population as well. So let's talk about some very common sampling methods that we use for an observational study. So because our goal is to make inferences about a population from our sample, it's very important that our sample is collected appropriately and representative of our population. So we have a list of about 6 ways that are very common methods of collecting data. And we'll talk about advantages and disadvantages of each of them. So the first one is convenience sampling. Its name kind of leads to its definition. It uses subjects are readily available. Its advantage, it's very easy to collect data if using convenience. It's also like if you're looking at someone who's like doing this as a job, it's very cost effective to collect data that way. The disadvantage and reason why it's not used very often is it's not representative of the population. So kind of like an example of how you would use convenience sampling, you've got a new policy at your school, so your principal stands outside the library and asks a few students their opinions. That's convenient. Not a lot of students maybe necessarily walk by the library, and so you want to if you're going to use convenience, you want to stand somewhere that is going to get you a lot more of a representation of your population. Next is something called voluntary response sample. So that's a sample obtained by allowing subjects to decide whether or not to respond. It's also called a self-selected survey in some instances, but we're going to refer to it as a voluntary response sample because it's voluntary whether or not you respond. It's very easy to collect data if you just send something out and you ask people to respond. Huge disadvantage to a voluntary response sample is it's going to overrepresent the people with strong opinions. Whether or not these are strong opinions in the positive or the negative doesn't matter. It's just the people who care the most about whatever you're sending a survey out about are going to be the ones who respond. So very common examples of these are polls. Whether or not they're polls where you call into someplace, polls that you get asked on social media or the news sends out. So like for example here, after the State of the Union speech, ABC tells its audience to call a number if they thought the speech was good and a different number if they thought the speech was bad. And there's a 50-cent charge for the call. So obviously the people who don't want to spend the money are like, I don't care enough to respond. But the people who really had a strong opinion, whether it was good or bad, aren't going to care about that 50 cents and are going to respond. So voluntary response sample, probably the worst method of collecting data, and we're going to talk about more in the next section about why it's a very poor way to collect data. The next one is something called simple random sample. I'm going to call it SRS a lot. The abbreviation is just a lot more common a way to see this written. So the way a simple random sample works is it consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance in the sample selected. I probably shouldn't use the same variable I used up above for here, so let's just change this to an R. What that means is you've got a set of individuals that you're looking at from your population, so that's your N. And you choose them in such a way that every set of those individuals has an equal chance to be in the sample that you end up selecting. So an SRS is the best and most appropriate way to collect data for a sample. It is the method that should be used at all times if possible. So we'll talk about more about how an SRS works in section 3. But some very common ways that you see it: it's easy to accomplish if you use a table of random digits, like you randomly assign people a number and select those. Another advantage to it is it produces samples that are a good representation of the population. There aren't really any huge disadvantages to it. I guess you could say it can be time consuming to get all of that information initially. But other than that, there's really no downside to it. So, for example here, in order to determine how happy students are with their education at DACC, the principal assigns each student a number from 1 to 1,200. Let's assume that 1,200 is the total number of students we have at the school. We then use a random number generator to choose 50 numbers between 1 and 1,200. And then all of those students that were chosen are then surveyed. So the time-consuming part comes from assigning a number to each student. So that's really the only disadvantage, is that time-consuming part on the front end. But other than that, it's a very good way to represent your population in a sample. The next two are very, very similar methods of sampling. So it's very easy to kind of get confused about the distinctions between the two. But the next one is something called stratified random sampling. So what you do is you divide your population into groups. Specifically groups of similar individuals. These groups are called strata, so that's where it gets the stratified name. You then select an SRS, so a simple random sample, within each strata. And then you combine the SRSs from each strata to form the full sample. So basically what that means is you have a group of similar individuals. Right? Your entire population is divided into groups of similar individuals. You then, from each of those groups, randomly select a certain number of people and then combine all of the people you selected from each of your strata, and that's your sample. So very good advantage to this is it does produce more exact information, especially if you have a large population. By taking advantage of the fact that individuals in the same strata are similar to one another. So it helps you get a good representation of your population. Now, the problem here is unless you define those strata very obviously, it can not necessarily be appropriate. So if your strata aren't very well defined, if you could say, well, I could place this person in potentially multiple different strata, then that could lead to a problem. So for an example here, so in order to get a better idea of what DACC students thought about their CTSOs last year, advisors divide all DAC students into the CTSO they are a part of, and then select a random sample from each CTSO. And our full sample consists of aggregating or adding the random samples from each CTSO. So it's very obvious what career technical student organization you're a part of based on your lab. So those are easily defined groups. We select a certain number from each of those groups, and that makes up our sample. The next one is something called cluster sampling. So very, very similar start. You divide the population into sections. Sections are called clusters. Then randomly choose a few of those clusters. And then every member of the cluster becomes your sample. So it's very similar to stratified in the way that you have groups, but kind of different here is those clusters that we create for cluster sampling, they don't have to be similar. You're just dividing them into groups. And then another difference here is you're randomly choosing a few of those clusters, so a few of those groups, not just people from every group. So the nice thing here is like you don't need a list of the entire population if you're just going to say, all right, we're going to break them down into groups. But the problem here is depending on how your clusters are determined, you can get more variability between your samples. Because it really depends on how you determined those clusters. So for example here, a psychologist at the University of Pennsylvania is collecting a sample by dividing students up into their respective schools. So you have like the Wharton School of Business, you have your College of Engineering, College of Nursing, College of Arts and Sciences, so based on what college they're a part of. And then by the departments that their major is in. So for like arts and sciences, there's like chemistry majors, math majors, there's a bunch of different. So those are the department. And then she selects a few of those departments at random and surveys every student within those chosen departments. So you're first broken into your cluster of school, and then within that you have your cluster of what department you're a part of. And so the departments are chosen at random, and you choose students based on that. The last one is called systematic random sampling. So for systematic, you randomly select an arbitrary starting point and then select every case member of the population. So when I say every case member, like you also pick a number, like I'm going to survey every 5th person or 20th person or something like that. So nice thing here is every member has an equal probability of being selected because you're doing a certain number of people. But the problem is, if you're thinking back to an SRS, not every sample of a specific size has an equal chance of being selected because you're randomly choosing when you start collecting data. Anyone before that doesn't have a chance of being selected. So for example, this is a very common method used in quality control in like factories and stuff. So like if you select every 200th computer off this assembly line and inspect it for quality control, so that's very similar to what they do in assembly plants and stuff like that, is they'll randomly select every so many just to make sure that there aren't any problems with it. So very easy, but not the greatest way to collect data. So a couple other kind of general things when we're talking about population. If an item can be selected only once, what we're doing is it's called doing a survey without replacement, which means once you have been surveyed, you can't be surveyed again. If it can be selected more than once, it's called with replacement. That's going to come up a lot more when we talk about in chapter 4, when we talk about probability. With or without replacement is going to come up a lot more then, but it does have a little bit of show up here when we're talking about collecting data. So when it comes to the 6 sampling methods we looked at, each method has its own advantages and disadvantages, and it's really based on the question that you're answering, so like what you're trying to collect data about, and then also the population that your sample is going to be drawn from. And we'll take a look at some examples and spend some time on how to determine which method is the best method depending on what the question is. Let me know if you have any questions, though, on any of these definitions.